Hello. Good morning, everyone. We hope you're having a great time in San Francisco. Thanks for attending Build, and welcome to the camera session. Can we see a show of hands? How many of you have worked with media capture before? It's great. Now, how many of you have submitted a camera app to the store? Good to see some of you, and we're here to get more of you on board. In this session, we will show you how easy it is to develop powerful camera apps for Windows 10. I'm Sandeep. Mike will join us later in the session. I want to remind you that it would be great to have your feedback once our session is done. Please don't forget about that. As you have heard in the keynote and various other sessions, convergence of APIs across various device form factors is a key theme this year. You can now build your app once and run it on all your Windows devices. We'll begin by covering some of the new functionality that you can leverage starting with Windows 10. And in order to get you started easily, we have some great universal Windows platform samples that Mike will walk us through later in the session. As part of convergence, we have combined the functionality of Windows Media Capture, also known as WMC, and Windows Phone Media Capture, also known as WPMC, into WMC. So features that were only available for a specific device form factor are now available across all Windows devices. For example, video stabilization comes from PC, while get preview frame comes from phone. Both of them are now available on all devices. This slide here shows a list of the functionality that you can leverage starting with Windows 10. Features that are marked with an asterisk are available only on devices that ship with Windows 10. Support for these features is discoverable through a property. In this session, we will cover the first 5 in this list through code samples and demos. First, let's take a look at software bitmap. Software bitmap is a data object representing image data and provides access to pixels. It has very good interop with many of the consumers and producers, which will be evident in the next slide. As you can see in this picture, software bitmap can be produced from an image file or stream using bitmap decoder or from the camera through captured frame. You can also create your own software bitmap in the desired pixel format and size. Lumia Imaging SDK will soon start providing support for software bitmap. And once that happens, all the effects in that library can be used. You can also create your own custom effects by getting access to the pixels. The same code then can be used on a video stream using iBasic video effect, which was covered in the audio and video creation session on Wednesday. From a consumption point of view, you can save a software bitmap to a file or stream using the bitmap encoder, or display it on the screen using XAML software bitmap source object. Currently, software bitmap is not displayed correctly due to a small issue. Rest assured, this will be fixed in our next flight. You will be seeing software bitmap in use in one of the samples that we demonstrate later in the session. These samples that are available today for you should cover most of the immediate functionality related to capture scenarios and camera functionality. Many more samples are under preparation and will appear on GitHub soon. In this session, we will be focusing more on the first 3 samples in this list. Preview frames are very fast to obtain because they involve minimal image processing. This is very useful for applications that do live analysis. For example, live translation services, barcode, QR code detection, etc. The get preview frame sample shows you how to get access to the current preview as a video frame object. So it also handles device rotation and media capture lifecycle management. Mike will show this in action and take us through a code review. Let's invite Mike.
Thank you. Thank you, Sandeep, for the introduction. Hello, everyone. My name is Mike, and I'll be walking you through some of our samples. All right. So let me prepare you for this. There is a lot of content in the samples that you'll see here. And I could spend hours here with you talking about creating camera apps and all the cool things that you can do in this space. But there's also a lot of great stuff going on later at Build that I wouldn't want you to miss. So this creates a little bit of an internal conflict in me. But I am going to have to keep it short. And that means skipping over some parts of the code, like some of our helper methods and some of our event handlers, and also skipping over demoing each of the samples on each of the devices. But all of these samples, like Sandeep said, are available for you to download right now. So if you haven't done so yet, please go and clone our samples repository. Try out the samples on your own devices. OK, so let's get started. And I'm going to start by showing you the compiled sample, just to give you an idea for what it is that it does. And we'll look for it here, the get preview frame right there. And you'll see that it launches straight to the preview, which means that it's taking care of initializing the media capture and configuring it for use. And it also handles device orientations. So anytime I rotate my device, the preview adjusts so that it always remains upright. We received feedback from you guys that this wasn't the easiest thing to figure out. So we wanted to make sure that with this sample, you'd have a good starting point for rotation as well. So I'm going to tap the Get Preview Frame button right here. And you'll see that next to it, a text block is populated with the dimensions and the pixel format of the frame. Now, on the Lumia 630 right here, that happens to be NV12 by default. But keep in mind that that may vary by device. Now, the API does offer an overload that allows you to specify the pixel format. It'll perform the conversion for you. And the sample makes use of that when we choose to show the frame in the UI. There we go. The current preview frame is now displayed to the right of the preview. And just below it, you can see that the pixel format has changed. Now, as a way for you to familiarize yourselves with the software bitmap, which is the underlying object doing all of this, we included some code that edits the pixels on the software bitmap to apply a simple green effect, and also some code that will save the frame to disk. Let's give that a try. That's it. By the way, you can have a lot of fun creating your own custom effects if you haven't done so before. Give this a try. Come up with your own algorithms. It's actually a lot of fun. So let me just show you the code behind all this. Get preview frame is a method on the media capture. So we're going to start looking in this region. And the method that is doing all of this is right here. So let me scroll over. And you'll see that the first thing we're doing is we're getting information about the preview stream at the moment. And that is because we're going to use the width and the height of the preview, along with our desired pixel format, to create this video frame, which describes the result that we'll get from the Get Preview Frame API. We pass that into the API, and it'll return us an object that contains a software bitmap. And that software bitmap right there is our preview frame. At this point, we're basically done. That was all we had to do. Now, to show you a couple more things that we can do with this, we go ahead and populate the text block that you saw with the dimensions, with height and the pixel format of the frame. And then depending on the state of the UI, the checkboxes, we edit the pixels, we show the frame in the UI, and we can save the frame to disk. Now, like Sandeep mentioned before, there is a small issue with displaying the software bitmap source in the UI right now. So for now, you might want to use this little workaround that we included here for you. But because we have the fix ready, and it's just waiting for the next flight to reach all of you guys, you might as well go with the recommended pattern for that. Don't worry, we will update the samples as soon as the fix is out. So because we just covered get preview frame, and there's a couple more things here that I want to show you, let's talk about rotation for a while. In this sample, we use the display information object to receive orientation change notifications. When those trigger, we go and apply the corrective rotation to the preview. And for this sample, I will show you exactly what the helper method is doing. So in the case that we're dealing with an external camera, there's no work for us to do. The assumption is a camera that is connected over USB is probably not being subjected to the same rotations that the actual device is. But otherwise, we grab the current orientation of the display, and we convert it to a number of degrees. Now, if the preview is being mirrored, and I'll talk more about that in a moment, we need to match that mirroring by basically inverting the rotation. And once we've done all of that, we can get the current media stream properties of the preview, add the information about the rotation to them, and then set them on the preview. This is the way we recommend you guys do preview rotation, because it saves you a lot of work. It's not actually doing pixel rotation. It's not applying that transformation to the frames. It's just adding the rotation information as pure metadata, which means the actual rotation work is being deferred way later until much closer to rendering. And if you think about it, you could be running the preview at 1080p or higher, 30 frames per second, and that's a lot of churn to be applying this transformation to all of those frames. So because this API was available on phone before, I wanted to demo it on my laptop as well. And I have it ready for you here. And you'll see the UI looks pretty much the same as on the phone, of course, universal apps. It also behaves pretty much the same. Notice it is a different format because it is a different device. And we can choose to show the frame. And let's also edit the pixels right away. And there we go, green effect. Oh, that is very unflattering, isn't it? Let's try for another one. All right, let's just drop that. You'll see that there's something a little weird going on, and what is that? I'm raising one hand on one side, and the preview frame shows the other side being raised, and that is because we are applying preview mirroring here. Now I'm raising my left hand right now, and on the live preview stream to you, it kind of looks like I'm raising my right hand, but that's because you're on the other side of the display. For me, the preview behaves exactly like a mirror. And this is something that users have come to expect from camera apps that use the front-facing camera. It's just a lot easier to fix your hair, check your teeth or something if the preview is behaving like a mirror. All right, so I think that's all I had for you for this sample. Let's bring Sandeep back in.
So let's now discuss about the camera capture sample. So the camera capture sample is a great starting point for capture scenarios, and it's very easy to extend. It basically provides you the functionality of photo and video capture along with a live video preview. It also allows you to do concurrent photo and video record if the device supports it. It also handles device rotation and manages your lifetime management of the media capture, just like the get preview frame sample. So Mike will take us into a deeper dive on this as well.
Excellent. Switch back to the computer. And again, I'll start off by showing you the sample itself. We called this one the universal camera sample. That's also the name that you'll find it under for in our samples repository. And you'll see this time the preview is a nice full screen preview with overlaid semi-transparent buttons. We went all out in the UI for this one. And there's two capture buttons on the side. So let's give them a try. Let's have you smile right there. All right, beautiful. And I'm going to record a short video as well and just pan across the stage. There we go. The lighting is really not working for us here, but that's fine. Now you'll notice the other capture button disappears when I'm using one of them. Keep that in mind for later. This sample actually shares a lot of code with the get preview frame sample. And later on, when you have a closer look at the samples, you will find all those similarities. There are, though, two major differences. The first one, of course, is the types of captures that we're doing. We're capturing photos and videos as opposed to getting preview frames. And the second one is the way we handle the orientation scenarios. And let me demo that right now. So you'll see that when I rotate the device, the buttons always remain on the same edge of the screen. Just like the navigation buttons at the bottom, they just rotate in place to adapt and remain upright. So let me start by showing you the code to do that. When we're setting up our UI in one of our helper functions, we declare an auto rotation preference. And you can think of this as a rotation lock within your app. Now, it may not always be granted. And the reason for this is that there's situations, there's scenarios like the desktop where you can have multiple apps. And one app shouldn't really prevent your whole environment from rotating or not matching the orientation of everything else. So even though we're declaring this, on multi-app scenarios, we still need to subscribe to those events, to the orientation changed events. And you'll find two different kinds for those in this sample. The first one we've seen already. It's the display information orientation change. This is part of the similarities that this sample has with the get preview frame sample. And this one will trigger whenever you see that rotation animation going on that the platform does for you before it updates the layout for your page. And the other one, this is what's new here, is the orientation sensor. And this one will trigger regardless of whether orientation lock is engaged or not, regardless of whether the auto rotation preference is being honored or not. And this is the method that we're using to update the orientation of our buttons. So all of this code is already implemented here. So have a closer look later on. Leverage it for your own apps. If you think about it, keeping the buttons on the same edge of the screen is basically the same experience that the Microsoft Camera app gives you. So it might be a little more familiar for users. It's something for you to consider. So let's get over to the actual capture side now. And we're going to start by looking at how to take a photo. Oh, and here's a little trick I want to show you. Remember when we were doing capture that one of the buttons always disappeared? When we were capturing a photo, the video disappeared. When we were capturing a video, the photo button disappeared. And that's because many Windows devices support capturing photos and videos at the same time. The Lumia 630 right here, being an entry-level device, happens to not support that. But finding out if that is supported or not on the device that your app is running on is as easy as reading this property. Now, if you want to take this to the next level, you should really have a look at the camera profile sample. That one will show you how to do concurrent capture with multiple cameras at the same time. Or for more granularity, it can tell you exactly what combinations of resolutions are supported for simultaneous photo and video capture. Sandeep will talk more about that later. Anyway, let's get back to taking a photo. You can see here that we are capturing a photo to a stream in the JPEG format. And then at the same time, while we're doing this capture, we're getting the current orientation of the camera. And we pass the current orientation and the stream to a helper method that will combine both and save in to a JPEG file in the pictures library. This JPEG file will support multiple orientations because of this. Now, recording a video is even easier. We start by creating our storage file. We create our encoding profile for the video, in this case, MP4. And then, same pattern as before. We get the current orientation of the camera. We apply that to our encoding profile directly. And then we can just start recording our video to the encoding profile, with the encoding profile to the storage file. There's no need for any helper methods that will do all of that rotation and file saving here. Now, because we're doing video recording, we recommend that you subscribe to the Record Limitation Exceeded event of the media capture. And you'll find that under our event handlers right there. This is an event that will trigger as a way to notify your app that it has exceeded the maximum length for a single session. The limit is set at 3 hours, which should be enough for most users to capture anything that they wanted to get in a single take. But this is how you can prepare your app for that scenario. And you'll see here we are stopping video recording at this point and updating our UI to reflect this. But you might want to go that extra step and try to start a new recording session so that your users don't miss anything that they may have wanted to capture. Another media capture event that is interesting is the media capture failed event. And this will trigger for a variety of errors. But most importantly, when your users unplug the camera, a USB camera, while it's being used. So all of the samples you'll see here today handle this in the same basic way. They log the error, clean up any resources that may still be in use, and update the UI to reflect that the camera is no longer in use. Again, you might want to go that extra step and show an error message, asking your users to behave, or asking them why do they start a camera app and unplug the camera, stuff like that. And while we're talking about events, I want to show you something else. You know that Windows phones have a 2-stage camera shutter button on the side. Many of them do. And for a camera application, this is very interesting. You can subscribe to events coming from that button. And I want to show you how to do that. The first thing you need to do is go over to your project references and add a reference that you'll find under Windows Universal Extensions. And it's the Microsoft Mobile Extension SDK for Universal App Platform. What a mouthful. Make sure that it has a check mark next to it. Click OK. And right here where we register all of our event handlers, you can see that we're checking to see if that type is present on the device that we're running on. This differentiates phones from Windows. And you'll note that phones from desktops and tablets. You'll note that there is no pound defines or if defs or even separate projects for this. So it's a much more streamlined coding experience than what you may have seen before. If this type is available, you can register for events such as the camera shutter button half pressed, camera pressed, and camera released, allowing you to do cool things like triggering autofocus on half press or recording a video only while the shutter button is completely held down, or even capture a photo sequence, a burst shot. So this was a lot of stuff, so let me do a quick recap of what we looked at. We started by talking about rotation and how there's 2 objects that are delivering the information that we need to handle all the scenarios, the display information class and the simple orientation sensor. Then we moved over to the captures, and we saw how to take a photo, how to record a video, and support multiple orientations, multiple aspect ratios. After that, we went over and looked at the recording at the events that the media capture raises that any camera application should handle: record limitation exceeded and media capture failed. And finally, the shutter button events, the hardware shutter button events that are just so interesting for camera scenarios. So all of these are basic features that any camera application should cover, and we already implemented them here for you guys to learn from or just leverage straight in your projects. Thank you.
Thank you, Mike, for that detailed explanation. Let's give a round of applause. The beauty of these samples is that they are highly extensible. We invite you to take these samples and customize them to your needs rather than reinventing the wheel. Our next sample demonstrates this extensibility. The face detection sample is a simple and direct extension of the camera capture sample. It showcases how easy it is to add face detection. All you need to do is insert the effect and listen to an event. On supported devices, it will also enable face-based autofocus and auto exposure, so the pictures that you're taking are well lit. Mike will demonstrate this extension.
All right. Okay, guys, this is my favorite part of the presentation. Like Sandeep said, I'm going to be showing you how easy it is to add face detection to your camera app. And again, let's just fire up the sample, see how it looks. There's that unflattering angle again. Oh, God. Anyway, you'll recognize the UI from the previous sample that we saw, the basic capture buttons on this side, plus the addition of a new face detection button on the other side. Let's enable that and see how it works. There we go. Oh, blue on blue might not work so well. But you can see the rectangle around my face. And as I move around, it's tracking me. So let's bring Sandeep in. Can you come into the frame? You need to be a little higher up. There we go. So we're tracking multiple faces. And you'll see that there's 2 different shades of blue being used here. And I'll explain why in a moment. Thank you, Sandeep. So jumping into the code now. There's basically 2 things that we need to do in our XAML to enable face detection. We decided to add a button. That's the first thing. And this button will enable and disable the effect. The second thing that we need to do is have some sort of control that will host all of the face detection bounding boxes. We went with a canvas, called it Faces Canvas. And you'll notice that it's actually wrapped in a second canvas. And this is because it makes it easier for us to deal with things such as rotation or letterboxing of the preview in case the preview stream doesn't match the aspect ratio of the screen that it's being displayed on, the size of your window, basically. Now, as for the code, there's 3 things that we need to do. We need to enable face detection, we need to handle the face detection events, and we need to clean it up. So let's look at how to enable it first. It's right here. And we start off by creating a face detection effect definition. And an effect definition is an object that allows you to set some of the properties on the effect that need to be set before the effect is actually created. For example, we choose not to run face detection synchronously because we wouldn't want to delay any preview frames just because the face detection effect is still running on them. Then we set the face detection effect to run in high performance mode over the other 2 presets that we offer, which are high quality and the balanced preset. So after we've done this, we can add the face detection effect to the pipeline, and we're adding it to the video preview. Face detection is an effect that you would want to run on the preview most of the time. This will actually return you an instance to the actual effect. And on that effect, you can subscribe to the face detected event. You can set a minimum detection interval in case you want to space out the events and maybe go a little lighter on the resources. And finally, you can enable face detection, and you are detecting faces at this point. Now, face detection, enabling it, can be as little as 4 lines of code. You don't need to do all of this, but I just wanted to show you some of the properties that you can play around with. Now, before we go over and look at the face detection events, I want to show you how to clean up face detection when you're done with it. As you can see, it's also pretty simple. In fact, if you know you'll be using face detection again shortly, you can get away with just disabling it and then re-enabling it later, which saves you all of that work of reconfiguring it and re-adding it to the pipeline. OK, we get to see the face detection events now. And I want to give you a little warning. This is what makes the bulk of the code. And this is because there's a lot of UI calculations being done here that are completely optional. You get all the benefits of the face detection effect, namely automatic exposure and face focus, just by enabling the effect. You don't need to highlight the faces in the UI, but it's a pretty cool thing to do. So I'm going to show you how that's being done. You can see that we're asking the dispatcher to update our UI by running this helper method on the list of detected faces that the event delivers to us. And this is another helper method that I will go into detail. And the first thing it does is, of course, clear any existing rectangles from the faces canvas. These are rectangles that remained from the previous event that we've received. So we throw all of those away. And then for each face that we've received, we, first of all, convert the coordinates of the face box, which is the bounding box around the face, from existing in terms of the preview resolution to existing in terms of the size of our capture element, which is our preview control in the UI. And we need to do this because there's probably going to be a scaling factor between the two. it's rare that your preview will run at the exact resolution that it's being displayed on the screen. This is nothing too complicated. It's basically grabbing each property of the face box, dividing it by the corresponding dimension of the previous stream, which gives you a relative value between 0 and 1, which you can then multiply by the size of your capture element in the UI. So once all of that is done, we just choose what we want our face detection rectangle, the highlight part, to look like. We're setting a stroke and a color. And right there is where you can see we're special casing the first face. This is where the 2 different shades of blue came from. And that's because the first face that you receive in this event is what we call the most important face in the scene. It's the face that will drive automatic exposure, and it's the face that will drive continuous autofocus to focus on that person. So after we've done that, we add our rectangle to the canvas. The face is being highlighted. And finally, if you remember from the get preview frame sample, I mentioned that we're not actually applying rotation to the preview pixels. All of that is being done downstream. So any rotation metadata that we've added to the preview stream, we need to match that rotation on the face's canvas. And this is the reason why it was wrapped in another canvas in our SAML when I showed you that. So hopefully that makes a little more sense now. It makes just calculations in this method a lot easier to deal with. OK. I think that's all I had for you for this sample. Face detection is pretty cool. Play around with it.
So what do you think about face detection? Great. Yeah. It's a cool feature. Now, let's move on to another cool feature. So prior to Windows 10, if users, if app developers wanted to add pause and resume functionality to their app, it was not possible. They basically had to create or capture multiple videos and merge them separately. We now have platform support to pause and resume a recording before finalizing it. It's very simple. You just need to call the
Let me switch you over here.
I'm sorry, we didn't switch over. So pause resume recording is that. So it's very simple. All you need to do is call the pause async API for the pause functionality and the resume async API for the resume functionality. We'll show a live demo of it in action right now.
So what I'm going to do for this demo is something a little different. And we'll switch first. I want to show you one of our internal testing apps. And I want to start, I don't know, I'm going to start recording over here. OK, there we go. So I'm panning, and let's find Sandeep. There he is. OK, just pause recording right there. Sandeep steps out. We record a little more. Let's just stop it right there. So I'm going to show you the video as well. What's great about pause and resume is that it gives you a very, very low latency. That pause event is happening exactly when you want it. OK, we got rotation working. Oh, there are all of our other captures. All right. You'll see the video playing back. And Sandeep gains the power to disappear. That's pretty cool. So as you can see, this feature enables those fun edit as you record scenarios that are becoming so popular now that sharing of videos is so prevalent. And even though it's a simple API to use, it still gives you control over whether you want that very low latency or whether you want to be a little easier on the resources. So when you look at the MSDN, pay attention to the behavior parameter that you pass into the pause method. Thank you.
All right. Thank you, Mike.
Let's switch you over.
OK. So now let's move to another feature that is more powerful than the features that we have seen so far. It's the video stabilization. So video stabilization can be enabled very similar to face detection. All you need to do is insert the effect, configure the recommended resolution, and start recording. We will show you a demo video showcasing the stability achieved through video stabilization. For the demo, we captured a scene using two entry-level phones set up side by side on this evaluation rig. One of the phones has video stabilization turned on, and the other doesn't have it on. Let's take a look at the demo video now. Folks, note that this is running in real time on an entry-level device. That's impressive. So we have covered the first 5 features in this list already. Let me step back and say that if you are working on a feature that is not supported on a device that you have, you can get started with the emulator. Let's focus on the rest of the features briefly. Video frame is a data object closely related to software bitmap and basically carries timestamps. It is more useful in scenarios where you have a video stream and you have a continuous flow of pictures. So it can also represent CPU memory as well as GPU memory. Next, geotag helper is an API that allows you to tag an image with the current geolocation of the device, even when the requesting app has been suspended or closed. This is very useful because the geolocation service can take a long time, up to 30 seconds, to return the current location. And by that time, the user may have suspended the app after capturing a picture, basically. Variable photo sequence allows an app to specify bracketed shots for capture. And this is a very fundamental block in computational photography scenarios. This was available only on the phone earlier, and now it's available on all Windows devices. We have received feedback from many of you that creating a flashlight application needs access to camera and consumes unnecessary resources. We have acted on that feedback, and now you can control the lamp, also known as flash, without access to camera on supported Windows 10 devices. Mike alluded to this feature earlier. The camera profiles is a great way to make the most of your camera. It helps you with a fine-grained discoverability of the concurrent capabilities of a device. For example, let's say there is a device that can support 4K resolution when one of the camera is active. And if it cannot support 4K, but can only support up to 1080p when both front and back cameras are active. In the past, such devices did not advertise the 4K resolution. But now it's possible, thanks to profiles, where you can discover under what conditions which resolutions are available. Smooth zoom allows a nice gradual transition to the target zoom factor rather than a direct zoom, which sometimes can be jarring. In the past, apps emulated this by calling the zoom API multiple times with small steps. This is now supported by the platform and is done in a performant manner. High dynamic range video is also available on supported Windows 10 devices. You might notice that high dynamic range photo is not listed here. The list here shows the APIs that can be found in the SDK available today. We are working on an advanced capture photo API that covers high dynamic range photo. It will be available when Windows 10 ships, if not earlier. Square video recording is a great use case scenario for Vine and Instagram apps, and we have enabled that. This is enabled in a much more performant manner, and apps don't have to do a lot of work to insert the effect and do the cropping. It's supported natively by the platform now. And scene analysis effect can help in enabling this automatic capturing of good pictures, balancing between HDR and cases where you don't need HDR. Scene analysis gives you an indication of when it is useful to capture a picture using HDR. It also provides some of the information on the camera sensor, such as exposure level, ISO values, and many more details. Finally, we have also done work to enable our enterprise customers to set policies that control access to camera. We hope you can leverage all of these and basically get started with the samples that we have available today. We are excited about this, and we hope you are too. Please welcome Mike to say a few final words.
Thank you. Guys, thank you for coming to Build. Thank you for coming to the camera session. As you saw, we've done some samples in a different way. They break away from our usual format of using the SDK template. And this is something that's new for us. So we're very interested in hearing your feedback. Do samples like this that cover end-to-end scenarios that behave almost like real apps, are they helping you? Or is this a good model to carry forward? So give us that feedback. Sandeep and I will be at the Insiders Lounge for the next hour and a half.
That's right.
And later on at the Expert Zone from 1:15 until 3 p.m. when everyone's packing up, you'll still find us over there. So come over, have a chat with us, maybe play with the samples for a little bit. Now, if you can't make it, or if you're watching online, then I invite you all to go on the MSDN forums, engage with us, engage with each other, give us that feedback, talk to us about the camera, the stuff that you like to see. If you have really pressing feedback, I want you all to send us an email. Send us that feedback at buildcamera@microsoft.com. You'll reach Sandeep, you'll reach me, you'll reach the entire camera API team. So let us know what your developer experience is like. Let us know the things that you think we did well, that we should keep doing, and the things that you think we can improve for you. Thank you very much.
Yes. Go ahead.
It looks like we have a question from the audience.
Yes, two somewhat related questions, but early on you had mentioned there was now the possibility of doing multiple camera capture on a desktop device or a laptop tablet. Is there any reasonable restriction to the number of, say, USB cameras that you can connect up?
It depends on the device capability. The underlying SOC also needs to support that. If the SOC supports it and it's advertised, it should be possible. So that's where the camera profiles feature comes into picture.
Thanks. The other question I was going to have is the number of your starred things like the HDR video and the like required a Windows 10 device. I assume that does not mean, say, a Nokia 1520 that's been updated to Windows 10. It means a new device.
Correct.
So the question would be, what would be the first Windows 10 device phone that we could get to test it out on hardware?
We cannot disclose that yet,
Okay.
but you'll soon hear about it.
Thank you.
Give a try. Give the emulator a try. We've updated it with a lot of the features that are available on Windows 10 launch devices. So that way you can get a head start with developing your solution before you can finally get one of those devices that we are also very excited about.
Exactly.
Thank you.
Hi, just a quick question. With the face detection, does the API offer any exposure to the decomposition or eigenvalues or whatever is used so that you can do facial analysis?
Not yet.
Not
but,
yet, okay.
But we are certainly welcome to hear from your use scenarios, and then we'll work to enable that.
Send us an email. Send us an email.
Or we can
telling
chat
us-
later if you have time. Yeah.
Does the scene analysis give you any information about like blur detection in your photos?
Not yet right now. Right now it is doing the high dynamic range prediction basically, But the plan is the scene analysis as a component to expand on what capabilities it has, basically. Okay. So great suggestion. Thank you.
Sorry, I want to know the detail of HDR video. So HDR video, you need to use high exposure and low exposure. So how do you get the one shot, only one shot?
Sure. So are you talking about the HDR video or the HDR photo?
Video.
Video.
You're looking at the video. Yes. So it depends on the sensor underneath. So there can be different technologies enabling HDR video. So depending on the sensor, it can be either of those. It can be a sensor that is able to capture both low exposure and high exposure at the same time, or it does some sort of a bracketing, basically. But that's a device level variation. However, the platform level, you don't have to deal with any of that. All you do is there's a control that you go and enable, and then if the device supports it, you're getting HDR video.
I see. Thank you.
A possible solution for this would be interleaving each row to expose at a different level.
Yes.
And that way you don't need to run your video capture at 3 times the frame rate and varying the exposure in between, right? So that would be an approach.
Okay. Thank you.
So on his question on dual camera, do HoloLens will be able to support dual camera?
Let's take that offline.
Okay. That might be a better question for the HoloLens team instead of the camera API team.
But this will support, right? It's a universal app.
Sorry, could you?
This is a universal app. It should support at least one camera.
Right. Definitely.
But
that's the promise of universal apps.
okay.
Right. How many more and other things we can discuss later, basically.
Does the SDK provide cropping, image stabilizing, the alignment, and like a receipt capture to convert to bitono, anything like that?
So the video stabilization feature, if you want to get it in a crop format, you can get that. It's your choice as an app developer. If you want it back into the full resolution that it came in, you can have that. That's where the recommended resolution comes in. We recommend a resolution, but you're not required to go with that, basically.
This is more for image, like you want to capture a receipt and align it and.
Oh, I see. So it's not supported at the image level. It's mainly for the video at this point.
I don't think we're talking about video stabilization here.
No, it's for image. It's for image.
Image stabilization?
No. He's talking about just processing images that have
processing
been captured.
images. So Lumia Imaging SDK has APIs that you can leverage to align images if you are interested in that. Yeah.
Oh, okay.
And as soon as they publish their update, you can keep all your data in the software bitmap and push it around to the different components that will offer you the functionality that you're asking about.
Thank you.
Okay. Sure.
All right. Please don't forget to evaluate our session.
All right. Thanks, guys.
Thank you.